Advanced Programming in Scratch. Chapter Serve. Mapping the stage, adding sound, animation, and making projects. In the previous chapter, we have learnt about sensing block, working of operators, and random block. Let us learn how to move the sprite according to the coordination of the stage. We will also learn to create an animation, record sound, etc.
Mapping the stage. The stage is the area in the Scratch window where sprites move and interact with each other in a project. The exact location of a sprite is important in some projects to create animation or stories. This is done by manipulating the position of the sprite on the stage. Let us learn how to do this. Coordinate system on stage. The location of a sprite on the stage is determined by a combination of two values called coordinates. The x-coordinate determines the horizontal location of the sprite, and the y-coordinate determines the vertical location of the sprite. The size of the stage is 480 pixels wide and 360 pixels high. Thus, the x-coordinate can range from 240 to minus 240, and the y-coordinate can range from 180 to minus 180. The center of the stage has x-coordinate 0 and y-coordinate 0. The x and y coordinates of the current mouse position are displayed in the x and y text boxes respectively in the sprite info pane. The image given below displays the coordinate system of the stage. Moving sprite on the stage. While programming a sprite to move to precise locations on the stage, keep the following points in mind. A positive x-coordinate is on the right side of the center of the stage. A negative x-coordinate is on the left side of the center of the stage. A positive y-coordinate is on the top side of the center of the stage. A negative y-coordinate is on the bottom side of the center of the stage.
The x and y number lines divide the stage into 4 parts, each called a quadrant. Each quadrant has a different combination of positive or negative x and y values. Motion blocks. These blocks will enable you to move the sprite to make simple games and animations. There are 2 types of blocks that you can use to move your sprite. Blocks for absolute motion and blocks for relative motion. Blocks for absolute motion. In the motion blocks category, there are 4 blocks which enable absolute motion. Block description. Go to x0, y0. Moves the sprite to the specified position on the stage. Glide 1 seconds to x0, y0. Moves the sprite smoothly from the current position on the stage to the specified position in the specified time, that is the seconds. Set x to 0. Sets the x-coordinate of the sprite to a specified position. Set y to 0. It sets the y-coordinate of the sprite to a specified position. By using the blocks for absolute motion, you tell your sprite exactly where it should go on the stage. Blocks for relative motion. Relative motion is not determined by the location the sprite should go to, but by the current position of the sprite. Block description. Move 10 steps. Moves the sprite forward by the specified number of steps. Turn right 15 degrees. Turn clockwise 15 degrees. It turns the sprite by specified angle in clockwise direction. Turn anti-clockwise by 15 degrees. It turns the sprite by specified angle in anti-clockwise direction. Point in direction 90. It sets the direction of a sprite. Change x by 10. It changes the x coordinate of the sprite by a specified value. Change y by 10. It changes the y coordinate of the sprite by a specified value. Point in direction. The point in direction block is a motion block. The point in direction 0 block points its sprite in the specified direction, rotating the sprite. The blocks use the 360 degrees in a circle. The direction towards 0 represents up, towards 90 is to the right, towards 180 is down, and towards minus 90 is to the left. Point in direction 0, point in direction 90, point in direction 180, point in direction minus 90. Example: let us use the motion blocks to turn and move the sprite. Step 1. Create a new project. In Step 2, in the scripts area, create the stack of blocks as shown in the image. The sample image for the projects are given below. So, by using blocks for relative movement, you tell the sprite where to point and move relative to its current position. You can always see the current style of your sprite's movement below the stage in the sprite list in the direction text box. Adding sound. The Choose a Sound button present in Sound tab provides 4 options to add sound in a project. The various options available for adding a sound are: Choose sound from library. Scratch has a built-in sound library. You can select this option if you want to choose any sound from the built-in library. Record. This option facilitates you to record new sound. You can select this option if you want to add your own voice in the script. Surprise! This option facilitates you to add random music in your Scratch project. Upload sound. Through this option, you can select any song of your choice. Recording a sound. To record a sound, in Step 1, click the Sounds tab. Step 2, go to Choose a Sound button and click Record option from the list, or drag Play Sound Pop Until Done block from the sound blocks and click the drop-down arrow. A drop-down list appears in which 2 options are available: Pop and Record. Select Record option. A record sound window will appear. Step 3. Click on Record button to record a new sound. On completion of the recording, click on Stop Recording button. After that, you can either save it or re-record it. Step 4. Once complete, the name of the recorded sound will appear in the drop-down list of the block. Select the record sound to add it. Example. Let us understand with the help of an example. Here we select a backdrop and the sprites that suits best for our song. Each and every time when green flag is clicked, the selected sprites will dance on the background music. Step 1. Create a new project. Step 2. Delete the cat sprite and add the 3 sprites from the dance category, that is, Anina Dance, Cassie Dance, and Champ 99 sprites from the sprites library. Step 3. Add the Greek theatre backdrop from the backdrops library and create the stack of blocks as shown in the image. Step 4. Position the sprites as shown in the image. Step 5. In the scripts area, create the stack of blocks as shown in the image for the sprites. Step 6. Click the green flag button to execute the project. The sample images of the project are given below.
Animation. In traditional animation, images are drawn or painted by hand on transparent celluloid sheets to be photographed and exhibited on film. Each image differs from the others in minute detail. The images are then displayed at a fast speed to create the illusion of movement. Today, most animations are made with computer systems using multimedia software. The amazing and astonishing visual effects that you see in science fiction movies and the cartoon films are examples of animation being used. Creating animation in Scratch. Animation in Scratch can be created using the various blocks that we have studied. The blocks that represent appearance, motion, position, and size can be used to create animation of moving objects. Example, let us create a simple animation in Scratch. We will animate the backdrop of the stage to change color. We will also animate some letters by changing color and rotation. Step 1. Create a new project. Step 2. Delete the cat sprite. Step 3. Add the night city backdrop from the backdrops library. Step 4. From the letters category in the sprites library, add the letters of your name. Here, we took the glow S, glow C, glow R, glow A, glow T, glow C2 and glow H letter sprites to spell Scratch. Step 5. Click the backdrop in the Backdrops pane and in the Scripts area, create the stack of blocks as shown in the image. Step 6. In the Scripts area, create the stack of blocks for each letter as shown in the image. You can specify your own values. These values are just a sample. Step 7. Click the green flag button to execute the project. Making projects. Project 1. Let us create an animation of an ocean scene using different sprites. Step 1. Create a new project. Step 2. Delete the cat sprite. Step 3. Add the underwater 1 backdrop from the backdrops library. Step 4. Add the following sprites from the sprites library: diver 2, starfish, shark, and jellyfish. Position the sprites. Step 5. Select each and in the sprite info pane. Type between 25 to 70 in the size box to reduce the size of each sprite. Step 6. In the scripts area, create the stack of blocks for each sprite as shown in the images. Step 7. Click the green flag button to execute the project. Project 2. Let us create a project where two sprites are conversing with each other. Step 1. Create a new project. Step 2. Delete the cat sprite and add the Devon and Abby sprites from the sprites library. Step 3. Select the Abby sprite and set direction in the direction text box to 90. Left, right. Step 4. Add the whole backdrop from the backdrops library. Step 5. Position the sprites as shown in the image. Step 6. In the scripts area, create the stack of blocks shown in the image for the two sprites. Step 7. Click the green flag button to execute the project.